December 17, 1944. In the frozen forests of the Ardennes, Belgium, a German officer of the 6th SS Panzer Army writes in his diary, "The Americans are not like the Russians. Their artillery is something else entirely." He describes it not so much as the volume of shells fired, but the speed, the accuracy, and the terrifying immediacy with which death arrives. For much of the war, German troops battling the Soviet Red Army had learned to endure massive artillery barrages. Ranging shots preceded bombardments. The pattern of shells made some behavior predictable. Dig in deeper, seek cover, cut exposure. But on the Western Front in 1943 to 44, facing American forces, German soldiers would discover that their old assumptions no longer held. Why the German experience was so different? Lack of warning. Soviet artillery would often begin with ranging shots. The enemy artillery sends a few shells to calibrate, giving warning. German survivors described this as a cue to brace. In contrast, U.S. fire direction quickly eliminated warning, no dramatic build-up, just the explosion. Rapid strike. The Germans measured their own artillery system as capable of firing missions in 8 to 10 minutes under ideal conditions. The Americans routinely achieved fire on target in around 3 minutes under combat conditions. Precision, not just volume. It was not simply more shells, but the way they were directed. Multiple batteries firing with a coordinated solution so that all shells landed almost simultaneously. Technological edge. New communication gear, FM radios, forward observers with infantry experience, mobile motorized batteries, and advanced ammunition, including proximity fuses, all combined to create what German veterans described as something new, a moment of shock. In Tunisia, a German veteran of the North African campaign described how his company heated coffee after assuming they had time. 3 minutes later, the Wadi erupted in fire. He counted surviving men, the rest were casualties. The overhead small reconnaissance aircraft that American forward observers used became a signal of impending doom. Why this matters? This first section sets up the key question. Why did German soldiers come to fear American artillery more than anything else in the war? From the vantage of history and first-hand German testimony, the answer lies in the transformation of artillery from a supporting arm to a dominant weapon system, one that left the enemy little chance to act, react, or survive. From chaos to coordination. What made American artillery terrifying was not any single weapon but a system. A web of math, radios, vehicles, and people. It turned artillery into a fast-reacting machine of precision destruction. Unlike the Germans, whose guns often operated semi-independently, U.S. batteries fed all data through a Fire Direction Center, FDC. Each FDC acted as a brain. It gathered observations from forward observers, converted them into firing solutions using pre-calculated tables, then issued synchronized fire commands to multiple batteries. The result? Concentrated, instantaneous barrages that fell to German troops like the ground itself exploding. Mathematics of war. In 1943, back in the US, hundreds of women known as computers filled rooms with mechanical calculators and logarithmic tables. They calculated firing data for every possible condition. Air temperature, wind, humidity, barrel wear, powder temperature, and elevation differences. These calculations were bound into compact firing tables carried by artillery officers in the field. Instead of performing time-consuming math, American officers could look up solutions within seconds. The Germans, lacking such standardization, still computed many variables by hand under fire. Time on target, TOT, the invisible barrage. The jewel of the U.S. artillery crown was the time on target technique. Different guns at varying distances fired at precisely staggered moments so that all shells struck the target area within 3 seconds of each other. To a soldier on the ground, that meant no warning. No whistling approach, no creeping fire. Just silence, then simultaneous catastrophic impact. Post-war studies showed that 2/3 of artillery casualties occurred within the first seconds of a barrage. TOT maximized that effect. Why the Germans couldn't match it? German artillery officers understood the theory but lacked the infrastructure. They had fewer radios, less centralized fire control, and limited ammunition. Coordination across units required multiple headquarters approvals, sometimes hours of delay. By the time their response came, the Americans had already moved. Voices from the field. A captured German officer wrote in disbelief, "Before we had computed firing data for counter-battery fire, American shells were already landing on our position, not random fire, but precise fire on each gun." Another diarist described TOT. "It is not artillery as we understand it. You hear nothing, then the world ends. Every shell arrives in the same second." Why it worked so well? The FDC system combined three American strengths: industrial mathematics, thousands of pre-computed solutions, reliable communication, FM radios with clear transmission, standardization, identical procedures across every unit, so any observer could call any battery for fire. By 1944, this process had matured into a lethal routine. A U.S. lieutenant calling for fire could bring down the weight of dozens of guns in minutes, artillery equivalent to a small airstrike. Firepower made in America. By 1944, U.S. industry was producing artillery pieces in numbers no nation had ever achieved. The standard light gun, the M2A1 105mm howitzer, became the workhorse of every infantry division. Each division fielded 3 battalions of 12 guns, 36 howitzers total, fully motorized, fast and precise. The gun could hurl a 15 kilograms shell up to 11 kilometers, firing 3 to 4 rounds per minute. It was simple to service, rugged, and accurate. More than 8,500 were built by war's end. The medium gun, the M1 155mm howitzer, fired a 43 kilograms shell out to 14 kilometers. Over 10,000 were produced. These formed the backbone of divisional and corps-level artillery, providing the destructive weight needed to collapse bunkers and strongpoints. At corps and army level came even larger pieces, 8-inch and 240mm howitzers. They could demolish fortifications that smaller guns only scarred. Yet all of these weapons could be moved rapidly by truck or half-track. Mobility as a weapon. American artillery was fast because it was mechanized. Trucks and half-tracks limbered, towed, and resupplied guns within minutes. After firing a mission, batteries displaced to new positions in under 30 minutes before enemy counterfire could locate them. In contrast, German artillery remained largely horse-drawn. Around 80% of German transport still relied on horses by 1944. Each gun required 6 to 8 animals and hours to limber and unlimber, particularly in snow or mud. Under fire, movement was almost impossible. A German artilleryman in Normandy wrote, "We watched American guns fire, trucks appeared, and within 20 minutes the battery was gone. We needed 2 hours, sometimes 4. We were fighting a 19th century war with horses against a 20th century enemy with engines. Ammunition without limit." The American arsenal did not only produce guns, it created the logistics to keep them firing indefinitely. Shells, fuses, and powder came in standardized crates, easily moved by conveyor, rail, or truck. The same fuse could fit multiple calibers, 105mm, 155mm, and 8-inch, simplifying the entire supply chain. German artillery, in contrast, struggled with shortages and variety. Different fuse types and calibers caused bottlenecks. Ammunition allocations dropped so low that German batteries sometimes fired only 2 or 3 shells per gun per day. American gunners could expend thousands. As one captured German officer said, "We fought a poor man's war against a rich man's enemy." Engineering precision. Rock Island Arsenal and other factories built American guns to exact tolerances. Interchangeable parts meant damaged components could be replaced in the field. German weapons, though often more elegant in design, required more hand-fitting and were slower to repair or reproduce. This industrial precision extended to training. American gun crews practiced constant drills until loading, sighting, and firing became reflex. The result: faster response, fewer errors, and unmatched consistency. Industrial might turned tactical advantage. Every step, from casting barrels to loading shells, illustrated what Germany could not match: scale. The United States transformed industrial engineering into battlefield dominance. American artillery units fought with confidence that ammunition and parts would never run out. The guns themselves were symbols of a deeper power, a nation whose factories, workers, and logistics were synchronized with its soldiers. The invention that bent physics to war, the variable time fuse, or VT fuse, was a miniature radar set that transformed artillery into a scientific weapon. Developed by engineers at the Johns Hopkins Applied Physics Laboratory, it contained a transmitter, receiver, and vacuum tube strong enough to survive 20,000 g of launch acceleration. As the shell neared the ground or a target, the reflected radio signal triggered detonation at the perfect height for maximum fragmentation. It was the world's first truly smart fuse. From the ocean to the Ardennes, the U.S. Navy first used the VT fuse at sea. On January 5, 1943, the cruiser USS Helena downed Japanese dive bombers near Guadalcanal with proximity-fused shells, 2 kills in 3 salvos. By mid-1944, the Navy relied on VT fuses for anti-aircraft defense. The Army kept them secret until December 1944, fearing recovery by Germany. When the Battle of the Bulge began, Eisenhower demanded permission to use them. Approval came on December 19th to 21st, and the result in Belgium was devastating. The rain of steel. Conventional artillery relied on mechanical timers. A small misset meant wasted shells. The VT fuse ended guesswork. Each shell sensed the ground and exploded 10 to 20 meters above it, scattering steel fragments downward in a cone of death. Tests showed VT fuses were 3 to 4 times more effective than contact or timed fuses. German infantry caught in open terrain suffered catastrophic losses. A corporal's diary read, "We had learned to go flat at the first explosion, but these shells burst above us. The fragments came down like rain. Men in holes died. There was no defense." The psychological collapse. The new fuse killed both physically and mentally. Soldiers who had survived years under Soviet artillery now found even cover useless. Fear of the demon shells spread. Some units refused to advance. A German officer described a near mutiny. The men would not move. They preferred capture to certain death under American artillery. The U.S. Psychological Warfare Division later reported that VT barrages caused total paralysis of maneuver. Numbers that tell the story. VT shells destroyed 79% of V-1 flying bombs over England. Ground use increased lethality by 200 to 700% compared with timed fuses. Each 105mm VT fused shell produced roughly 3,000 square feet of lethal fragment area versus 60 square feet for a standard burst. Eisenhower called it one of the most important technical advances of the war, second only to the atomic bomb. Science meets industry. Factories in New Jersey and Pennsylvania mass-produced millions of these precision devices. Each required miniature vacuum tubes and circuitry that laid groundwork for post-war electronics. The VT fuse was proof that science, engineering, and industrial organization could alter tactics overnight. When the first shells exploded above the Ardennes, they announced not just firepower, but a new age of technology-driven warfare. The final judgment. For German soldiers, the VT fuse erased their last refuge, training, cover, or luck. Captured mathematician Hedman Vera Hoffman wrote after the war, "The Americans have taken the art of artillery and transformed it into an industrial process. The proximity fuse was its most perfect expression." The story ends where it began, with industry, doctrine, and relentless logistics. By late 1944 and early 1945, German artillery faced collapse not simply because of individual defeats, but because the entire system that made artillery effective had been dismantled. First, logistics. American depots and convoys kept batteries fed with shells, fuses, and spare parts. Ammunition trucks and railheads shortened resupply times. The result was an ability to sustain intense, repeated barrages. German supply lines, in contrast, were fragmented by strategic bombing and interdiction. Rail nodes were wrecked. Fuel and forage were scarce. German batteries that remained intact quickly ran out of the shots they needed to contest fire superiority. The images of Allied ammunition convoys and deserted German park positions tell the story in one frame: abundance versus exhaustion. Second, command and control. The Fire Direction Center model allowed the Allies to concentrate fire across corps and army boundaries within minutes. American forward observers, supported by L-4 aircraft and FM radios, could summon division or corps assets the same hour. German doctrine and staff organization rarely allowed such flexibility. Approval chains delayed counterfire. When German guns did reply, they were often too few and too late. Allied FDC photos and plotting boards show why. They were brains faster than the enemy's reflexes. Third, mobility and survivability. Allied batteries displaced rapidly after firing. Motorized logistics and trained crews meant fewer losses to counter-battery fire. German horse-drawn and undermanned batteries could not avoid destruction once located. Photographs of ruined German guns and the preserved motorized Allied batteries show this contrast starkly. Fourth, technology and weapons synergy. VT-fused airbursts, TOT strikes, FDCs, FM radios, mass production of reliable howitzers and standardized ammunition created an ecosystem. Each element multiplied the others. Where German weapons were sometimes technically excellent, they lacked integration at scale. Allied maps showing interleaving artillery ranges and units illustrate how any German concentration would be enveloped by overlapping fire. The tactical effect translated immediately into strategic consequences. German offensive options narrowed. Massed attacks would be shredded. Dispersed forces lacked punch. Mobility was lost. The Ardennes offensive itself shows this dynamic. Initial surprise produced tactical gains but not operational success. Once Allied artillery found German columns, the offensive stalled and then reversed. Casualty reports and prisoner testimonies consistently attribute far more losses to artillery than to tanks or infantry in many engagements in the West. The collapse also had psychological and institutional effects. Units that survived the worst bombardments surrendered morale and cohesion. Many German soldiers later said artillery, more than tanks or aircraft, was the weapon they feared most. German command, facing industrial shortfalls and shattered logistics, could not rebuild training or material. When the Wehrmacht collapsed, it was not for lack of bravery but for the inability to reconstruct the industrial and logistical base artillery depends on. Finally, the legacy. Post-war armies studied these lessons immediately. Time on target, centralized fire direction, forward observer integration, and mechanized resupply became staples of NATO doctrine. The VT fuse pushed research into proximity and programmable munitions. Industrial standardization and mass production remained central to force design. Modern artillery is a descendant of the American system that dominated in 1944 to 45, faster, digital, but conceptually similar. Sensors, a centralized brains, precision munitions, and logistics that sustain volume. A single image captures the conclusion. Captured German artillerymen standing amid the wreckage, watched by Allied signalers planning the next fire mission. The era when individual skill could consistently overcome systemic advantage had ended. Warfare had shifted from individual heroics to integrated systems. The American artillery system did not only win battles. It rewrote how nations think about firepower, logistics, and the industrial base necessary for modern war. In the frozen forests and open fields of Europe, it was not the biggest tank or the loudest plane that most often decided a fight. It was the silent mathematics of artillery, delivered on time, in volume, and without mercy.